Hi guys, welcome back to another math video. Today we're going to be doing some Calc 1. This is recommended. Let's see if I can get even more lighting here. Neither look good, but we're going to do with what we got. Okay, so our goal is to find dy dx of this function here, right? That's our goal, okay? So how are we going to start, you may ask? Well, we need to start by thinking about what dy dx is. Dy dx is that we're going to differentiate y with respect to x. We're looking for the change in y with respect to x. So essentially, partial differential or implicit differentiation is like we're going to have a function of multiple variables, but we're only going to be differentiating in respect to one of those variables. So the rest of them will just be like dx dt or dx whatever. So in this case, we're going to do, we notice that we have a product, right? We have two functions being multiplied together, x squared and the linear function y. So we're going to have to do the first times the derivative of the second, right? So that's going to be x squared, okay? Derivative of y is just 1, right? We agree with that. But because we're differentiating y with respect to x, we're going to have to multiply that by dy dx, okay? Now, plus second times the derivative of the first, 2x, and we're differentiating x in respect to x, okay? Now, plus first times the derivative of the second, x, times, so now we're going to have 2yx, differentiated y, right? So now we're going to have dy dx, okay? Plus y squared dx dx, right? And this is equal to derivative of a constant is 0. Cool. Now we're going to think about what is dx dx in this case. And it's a little hard to see. I'll bring it a little closer if I can. I'm sorry for the light. It's such a difficult. I can't even see it. Oh god. Okay. Uh, yeah. So I'm gonna hold the flashlight here. It looks worse. Okay, there's nothing I can do, guys. This is the best I can do. So we can see that we have x squared, and so we have dx dx here, right? But the thing is, dx dx is just 1, because anything over itself is just 1, meaning that we can ignore these two, right? So now we're gonna have now we're gonna have x squared dy dx, yeah, plus 2 yx, okay, plus 2yx dy dx plus y squared, right? What do we want to do here? We want to bring the things, the terms without dy dx to the other side. That way we can that way we can factor dy dx out and essentially solve for it. Because this is just an algebra problem at this point, right? Solve for dy dx. That's what we're solving for, okay? So by doing so, we're gonna get x squared dy dx is plus 2yx dy dx is equal to negative 2yx minus y squared, just subtracting these two over. Then we're going to factor out a dy dx from the left side here, leaving us with x squared plus 2yx. And if we think about this move here, this would make sense, because if we multiply dy dx in using the distributive property, we're going to end back up with this, right? That would make sense. That should make sense, okay? Then we're still going to have that equal to negative 2y xy, doesn't matter. Multiplication is commutative. We're going to divide both sides by this, so we can isolate dy dx as if it were u or any other thing we're trying to find. And here we go. And that's our solution here. So yeah, hope you guys enjoyed. Just to review the steps one more time, we're going to differentiate both sides with respect to x, meaning that every time we differentiate y, we need to add a dy dx. Then we're gonna move our terms without dy dx to the other side, and then we're gonna factor dy dx out and essentially solve the equation.